Hope everyone is doing well. Seth with Glowe Voltage here, and today we're going to be testing speaker terminal cups that we got from Amazon. We got a couple of different types here. We got a spring terminal which you push down and it locks the wire in place, and we also got a screw down style where you screw down the terminal onto an insert for the wire. These are the push terminals, as you can see. The back here is pretty similar between both, which I feel like is one of the inherent problems here, but we'll discuss that later. And here's the screw down terminal. You can just put your wire or a ferrule or even a banana plug you can plug into the top of these, but most people just put the wire in and screw those down to secure them. And then on the back it uses a quick disconnect wire style. So basically the current flows through and goes through this kind of screw and then bolts down to these plates of metal here, which is where your disconnect goes on. A problem I did observe with both is if I twist the connection on the back, especially relevant for the screw down type, we can see that this isn't that secure of a connection, and the connection piece actually will rock back and forth. First, let's go ahead and test the resistance of both of these cups to see what kind of resistance the current will see going from the input to the back output. So when I connect it right here, I'm seeing about 2 milliohms. That is not great. But something I do like to do is disconnect them then and reconnect the meter. This is very sensitive, so I like to see that I can get duplicate results, just kind of confirming that my readings are okay. So I think we can confirm that right around 2 milliohms for the push spring terminals. Okay, there's simply no way that it's actually over 50 milliohms here, so this has to be a loose connection. I'm going to tighten up the nut on the back of this one and make sure that that's not causing a bad reading. Okay, so we got everything tightened, and now it's time to test this again. Still a really bad reading, but I made sure that everything was tight, so I am much more confident in this. This one says about 24 milliohms or so. I'm going to go ahead and test it a second time just to make sure. Okay, so it does seem to be consistent right around the 23 to 25 milliohm mark. For the wiring portion of this test, I will be using 10 gauge OFC speaker wire from New Concepts. And I have sped this portion of the video up, but I did want to include making the actual connections. I wanted to make sure that people could see that they were properly crimped, that it was properly stripped, that it wasn't user error causing any problems that we may encounter. So a quick test on this run of wire. I believe it's approximately 4 feet long. It might be 3 feet. I'll need to go back and measure, but it looks like it's about 4.3 milliohms. Second test to verify I can get a similar result. 4.3, so we are good to go. I'm going to be using a 1/4 inch quick disconnect, and it is for 10 to 12 AWG wire, and my crimpers actually have teeth specifically for heat shrink terminals, so I'm going to get that set up and go ahead and make sure that this is crimped well. Afterwards, I always like to give my crimps a visual inspection as well as genuinely try to pull the connector off the wire. Make sure that I can't, pull it off, shouldn't be, able to be slid off at all, really. Next, I'm going to cut this run of wire in two. That way we can use it for internal and external connections through the terminal cups. Make sure that all the strands are good, that I didn't accidentally, cut half of one off, and get ready to hook these up to the terminal cups. I'm going to go with the push terminals first. Go ahead and push that wire in there and just let it naturally clamp down, and then slide this over the connection point. It is a little bit loose, so I make sure to move it to where it feels more secure. If it causes a bad reading, we'll revisit that, but I think we should be okay. It looks like it's about 7.4 milliohms. And this is right around what we should expect, knowing that when we measured the wire, it was about 4.5 and the terminal cup itself was over 2. Next, for the screw-down type, these measured much higher when we tested the connection point from the inside to the outside of the cup. So we should see something similar here, but with some resistance added for the wire. And right out of the gate, it is around where I would expect, about 25 milliohms. Based on our reading, that's right where we expected to see it. So for the actual test, we're going to pull 60 amps through these. And why 60 amps? Because that would give us about the equivalent of 3,500, 3,600 watts or so from an amplifier into a 1 ohm load. So not insignificant power, but nothing too crazy either. First, I am making sure that nothing is, hot to begin with. Do a check here, make sure it's picking up heat, and then we'll begin the test. Turning the load on now and preparing to monitor the heat output. And almost immediately we start seeing temperatures rapidly spiking up. And within a few seconds we definitely have smoke coming from our connector, as well as temperatures in the 400 degrees. And even more concerning, this terminal has burst into open flame, so I went ahead and stopped the current. And you can see here it's melted clear through. The terminal's now easily movable from the plastic that was holding it a minute ago. last temperature check, and a couple spots are still well over 200 degrees, but it's cooling down fairly quickly. And now to test the other speaker terminals, I have them hooked up here, and we will start the load in just one moment while watching the temperature. And if you see the red dot, that's actually a laser indicator from my thermal cam. We have started the load. As you can see on the monitor, we are at about 60 amps. And once again, immediately we have temperatures spiking into several hundred degrees. Now, just like last time, things are starting to smoke, and the plastic is just melting on the terminal. This would be a direct short circuit because the terminals are not touching, because, you know, once again, it's destroyed. This can no longer be used. The plastic is melted and the connection points have burned. Now it's time to have some fun. We're going to simulate 10,000 watts. I did get a different style of the quick disconnects just to make sure that the brand I was using wasn't the cause. So I'm getting this set up for 100 amps. Sorry about the shaky camera here, guys. I was not expecting this violent of a reaction. I am glad that I had it cut on a second camera as well. So look at how violently this literally explodes, and it eats right through the terminal. Temperatures well over 400 degrees with, I did see a spot at a little over 500. And keep in mind, that was just from a second or two of that amount of current, so definitely not what I was expecting. And kind of funny, the aftermath, I have black plastic just kind of floating around my warehouse now. It stinks pretty bad, but I was just kind of surprised because it's very fluffy black plastic just everywhere. And here's a close-up of the aftermath. You can see where the metal plate actually blew off into my disc. And here's the different camera angle that I'm glad that I had set up. Very quick. Here's a slow motion, kind of a frame by frame of how quickly this happened. Definitely toasty. And here's the aftermath where it literally blew that piece of metal off and launched it into the quick disconnect. What's kind of scary is from the front, you may not even be able to tell things are going terribly awry behind those connections if this is installed in the speaker box. And this is where you can see that it is stuck inside of the disconnect. I wasn't able to remove that. And there's something about this design that I actually wanted to discuss and why it's inherently a terrible design for conducting current. With a good style of pass-through, we actually either bolt down or, like use a nut to tighten our ring terminal with our wire directly to the conductor on both sides. So on the left, I have an example of using a nut to secure the ring terminal down to the conductor, and on the right, I have an example of if you were to bolt the ring terminal directly to the conductor. And on the lower right, I have a couple of examples where the conductor actually goes all the way through the pass-through, allowing you to make a good connection on both sides. The way the speaker terminal cups pass the conductor through is, it has the larger area on the outside, and then it goes into a threaded screw on the inside. The problem with this is then when I want to use a nut to tighten down my ring terminal, I'm actually tightening that against plastic, not against a conductor. As you can see from the overhead view, my ring terminal isn't really making a great connection with the conductor itself. And the result is now I have my nut screwed in, or tightened on, and it's the threads of that where it's making the connection with the conductor. So my current actually has to flow through the threadings, then it's connecting to the nut, which then may also be passing the current through to a washer before the connection to my actual ring terminal, which is where the wire gets to carry the current on from. And most of the time, this is stainless steel, which is a poor conductor to boot. That's about it. If you have any questions, please let us know. Quick reminder, we don't have a horse in this race, so we're not making any money. We haven't been paid to make this video. We don't even sell this style of pass-through, so we really, we don't have anything to gain by, releasing any kind of false information. So just wanted to make that clear. We're not being paid for this. That said, I know that some people do swear by using pass-through speaker terminals, so if that is something you're interested in, I would recommend making sure that you get it from a reputable brand. Absolutely not the generic ones available on Amazon. For anything else you may need 12-volt installation wise, the best fuses around, the best distribution blocks. We do have a horse in that race. You can check us out at www.glowevoltage.com, and rest assured that we are only selling the absolute highest quality materials, and we can prove it with the testing. Just let us know if there's anything else you would like to see. Any questions, leave them in the comments below. And have a good one, everyone.